Hi guys, welcome to the Pepcoding. In this video, we are going to solve find minimum in rotated sorted array. So we have given a array which is rotated and sorted, and we need to find the minimum element from that array. So how will we find? Let's see. Let's say we have this array. Here we can see there are two parts where this part is sorted and this part is also sorted. This is the part 1. This is the part 2. So here we can see if we want the smallest value, the smallest value will be in the second part, which is here, and 1 will be the smallest. Now this rotation is done like this: 1 2 3 4 5 6 7. Here these 4 elements are came in front of 1. This means this will rotated like this: 4 5 6, then 1 2 3. So this is the rotation by 4. Now if we want to do this in O of n time, it can be easily done. How? We will traverse from 0 to the length till a element come whose previous value is greater than that. If this is true, this means this is the smallest value and we will return this value. But for doing this, it is taking of n time. And can we do this in of log of n? We can use a better approach than linear search. We can do this in log of n. How? We will figure it out. Let's see. This is a rotated sorted array. In a sorted array, for finding any element, we can use binary search, and it will find the data in log of n time. And we need the minimum element from this. Here we can see the minimum element have a property that if this is the minimum element, the previous value of this minimum will be greater, or if this is the value, its next value will be smaller. So the next value will be the minimum. Here that value will be the minimum. So this is the case of a minimum value to find. Now we are going to use binary search. This is the low, this is the high. Now we will find the mid. Where is the mid? 0 plus 9 divided by 2. Low plus high divided by 2. We have 4. This is the mid. Now we will check the condition. This is 4, this is 10. Is the next value smaller than that? If it is, then next value will be the smallest value. But here we can see the next value is not smaller. Now we will check, is the previous value greater than me? If it is, then I am the smallest. But this condition is also false. Here 9 is smaller than 10. Now this means the mid is not here and not here. The minimum value is not here and not here. Now what we need to do is we need to discard the sorted area, because we want the smallest element. So smallest element will be in the unsorted area like this: 11 1 2 3 4 1 2 3. So we need to discard the smallest area. So for sorted area, so sorted area is from 6 to 10. So for discarding this, we will check, is my array at low is smaller than equal to array at mid? If this is true, we will update the low by mid plus 1. This means our left side is sorted and the smallest value will not be there. So we will update low from there to mid plus 1. Now again we will find the mid. Mid is 5 plus 9 divided by 2, that is 7. I have written this wrong. This is 7, this is 8. Well, let's update our value again. Let's add a value here. This is 4. Now 8, 7, 7 and 8, 7, 8 and 9. Now here the value is 7. This is the mid. Now at mid, first we will check is my next value is smaller. If it is, this means the next value is the smallest value. Else we will check is my previous value is greater. If it is greater, then I am the smallest value. Here we can see this is false and we were at 7. Both conditions false. So we need to discard the sorted area. Now sorted area is, first we will check array at low is less than or equal to array at mid. Here we can see low is 11, mid is 2. So this condition false. Now we need to check is my array at high is greater than or equal to array at mid. This means this area is sorted. So we will discard this. For discarding this, we need to move our high to mid minus 1. Now high will be mid minus 1. Now we are at 1. This is the high. Now we will check the mid again. We will check the mid again. This is the high. Now mid is at 5 plus 6 divided by 2, that is 5. Mid is here. Now we will check is my next value is smaller. Yes, the next value is smaller. So the next value will be the smallest value. We will return this value. Here we get the value. So let's write the pseudo code where the conditions were if the array at mid is smaller, if array at mid is greater, first condition is array at mid is greater than array at mid plus 1. This means array at mid is the answer, mid plus 1 is the answer. So we will return this. Else we will check is the first value, that is before the mid is smaller than array at mid minus 1. This is the condition when, let's say we are at here 4, 5, 1, 2, 3. We are here. First condition was is mid greater than array at mid plus 1. It is not true. Now we will check is mid is less than mid minus 1. This is mid minus 1. We will return the array at mid. This means the before value is greater. This means I am the smallest value. If these both are false, we need to discard the sorted area. Array at low less than or equal to array at high. If this is true, this means we need to discard the left part. So low will go to mid plus 1. Else, if array at mid is less than or equal to array at high, this means here array at mid, that is from low to mid is sorted. If this is true, this means we need to discard the left. Now here if mid to high is sorted, this means we need to discard the right part. So high will be moved to mid minus 1. So this is the pseudo code. Let's write this. Now we need low, which is 0. We need high, which is array dot length minus 1. Now while low is less than or equal to high, find the mid. Mid is low plus high divided by 2. Now the condition were if array at mid is smaller than array at, if array at mid is greater than array at mid plus 1. This means we need to return array at mid plus 1. This means the next value is smaller. The next value is smaller of the mid. This means the next value is the smallest value. Else if array at mid is smaller than array at mid minus 1. This means the previous value is smaller. So we need to return the array at mid. This means array at mid is the smallest value. Previous value is greater. This means array at mid is the right answer. Now else we need to discard array at low less than equal to array at high. This means the left part is sorted and the answer will be in the unsorted part. So we need to discard the left part. So low will be go to mid plus 1. As we will check array at mid. This is mid. We are checking from low to high. From low to mid. From low to mid. If they are sorted, then we will discard. Then we will discard them. Now this is the condition when array at mid is less than equal to array at high. This means from mid to high they are sorted. This means we need to update our high to discard the right part. High will be updated by mid minus 1. Now this is the case. There is one more case. Let's say we have an array which is already sorted. That is 1, 2, 3, 4, 5. Now what will be the smallest value? Do we need to do the binary search? If we write a check that if array at low is less than equal to array at high, this means our array is sorted. So we can return the array at 0. This will be the smallest value. This is the smallest value if array is already sorted. So here before the while I am going to write if array at low is less than equal to array at high. This means it is sorted, so we will return array at 0. Now this is the code. Let's run this. So let's submit this. So it is accepting all the test cases and we have done this in log of n by doing binary search. Let's take this code to the open board for a small dry run. Where here is the code. This is the code. Let's take in data which is 4, 5, 6, 1, 2, 3. Now the low is at 0, high is at 0, 1, 2, 3, 4, 5. High is at 5. Now it will check is my array already sorted. If it is sorted, we will return the array at 0. But this is not sorted. Now we will run the while loop. Now at the while loop, first find the mid. Mid is low plus high by 2, that is 2. Now we are at mid. This is 2. Now we will check is array at mid here is greater than array at mid plus 1. The mid plus 1 is 1. Yes, it is true. This means this is the smallest value. We have written the 1. Now let's say instead of 1, there is 7. Now this condition will false that array at mid is greater than array at mid plus 1. Now it will go to the second condition, array at mid is less than array at mid minus 1. So array at mid is 6, mid minus 1 is 5. So this condition is also false. Now it will go to the next, array at low less than equal to array at mid. This means low is at 0 and mid is at 2. So 4 to 2, they are sorted. 4 is less than 6. So we need to discard this. So for discarding this, low will be go to mid plus 1. So mid was 2, low will be 3 now. Now again it will find the mid. Mid is 3 plus 5 divided by 2. That is 4. So mid is 4. Now again check. We are here. Array at mid is greater than mid plus 1. Mid plus 1 is 3. No, it is not. So this is false. Now it will check next. Array at mid is less than array at mid minus 1. Yes, it is. So this is the smallest value. We will return this. So these are the simple test cases we have tried and on. And hope this makes you more clear to see the code, how it is working. So this is the code and we have already submitted this. Hope you understand this. Please like the video, share the video and subscribe the channel. Thank you.